All right, I'm mixing it up for project 2 and beyond this semester. Rather than do a combo discussion project printout video, I am separating them. In fact, if you've already watched the printout video, you know that I've created a video where you'll get the printouts for the rest of your projects this semester. One-stop shopping. So when you're generating your printouts, watch that video and don't just get the one for this project, but get the ones for projects 3 and 4 too. You'll thank me later. Save them in a file and we'll come back to them. All right, so in this video, the main purpose is to discuss what it is I'm having you work with. The second part of the class is all about distributions, my friend. Binomials, normals, discrete, continuous, sampling distributions, you name it, we got it. And the project's going to let you work with it a little bit. Some of it's going to be your data and some of it's not. For instance, this first question, you don't really have a lot of data that can be useful here. So I just made up a problem and you're going to work with it. Again, with projects, you're working on your own. You're submitting the work. Start soon. Of course, some of you guys are waiting probably to the deadline to watch this stinking video, and you're going to get what you asked for here. Work early and get your questions answered. We'll be happy to talk to you guys about this. Anyway, first one, unemployment. Big concern being people laid off due to the coronavirus pandemic. It's estimated 20% of all households have been directly affected. Suppose we randomly sample 25. Those are two numbers that are interesting. And determine the number of households that have been directly affected. Have you been affected or not is kind of the question of interest here. Identify the type of distribution. We've looked at two main types in class, or by the time this stuff is due, we'll have looked at two main distributions. The next problem is decidedly a normal problem. I wonder what this could be. When you're working with the other type, when you're working with binomials, you got to have a value of n and p. So identify the binomial that you're working with here, and then show me you know how to work with it. In class, we've talked about dots. I've shown you how to solve binomial probabilities. I've shown you how to picture them using dots. Please do that here. If you don't put that in your answers on the project, at least think through it. Find a probability at least 6 of these 25 sampled have been directly affected. Find a probability at least 4, but no more than 8. These are probabilities that I wish you would solve. They're really, really challenging probabilities, and with the tool you're going to use here, they're pretty simple to solve. Now go through the binomial work, make sure you can do it, become experts at it really. And once you learn how to use the binomial tables, there's really no excuse not to be an expert. The only reason you're not an expert is because you're lazy, because you haven't put the time and the effort in. And so do that. And like I said, the TAs and I will be glad to help you with that. So question 1, pretty straightforward, pretty typical. You'll see some more in the competency checks. You'll see some more on your project, or on the exam, the second exam. So get to work. All right. Question 2, I want you to do some normal stuff. Look, I even drew some normal curves for you here, but I want you to use your data. So I want you to tell me your size or mileage of your 20th and your 40th observation, and just type them, write them, however you're doing the project, write them in these spaces right here, just so we can see that what the 20th and the 40th. The printout is just the mean and the standard deviation. So I want to know what the mean and the standard deviation of your mileage is, what your sizes are, put it in here. And I want you for this question to assume that those are population values. So that's mu and sigma. I know you got it from your sample, but I want you to work with normal curves. So pretend, assume, however you want to say it, that those are the values of mu and sigma from a normal population. And then I want you to tell me the probability. I want you to go through the steps. I want you to tell me the probability that that normal random variable will be between the 20th and the 40th observation. So draw me a picture. And to get full credit, I need a nice X picture drawn here, so where you put the 20th and the 40th and your mean in there, and then you're going to change them to z-scores. That's how we solve normals. How do you solve normals? You go through the z-score. So change them to z-scores and then show me the z picture. And then you can go to your table. Now the table that I'm using in class is the inside probability table. If you Google it, there's a good chance you're going to do a cumulative table. They both work. It doesn't matter which one you use, but the probabilities you find from that table or from that software that you're using, however you're finding the probabilities, I want you to show me where that is. Shade it in, put an arrow to it, and tell me what the probability is. Show me a probability somewhere. And actually for this problem, you're probably going to need 2 of them and then solve the question. So lots of stuff going on. Again, a very straightforward normal problem where I'm asking you the probability between 2 points, between your 20th and 40th observation. Obviously, everybody's problem is different because you all have different data sets. For part B, I want you to use the same mean and a standard deviation that you worked with in the last one, and locate the 9th percentile. Find the point in the distribution where 9% fall below and 91% fall above. And you're going to need a table again. And again, depending which table you use, you may be looking up different values. But show me the work. Show me as much work. Don't just put a number down there, because if that number's wrong, you're not going to get any points at all. Draw me a picture. Show me what you're doing. Question C is no longer just a normal. It is a normal. Well, it's a sampling distribution, which involves a normal. So suppose you take a future sample. You're not working with 75 now. You're going to take a different sample of 100 sizes or mileages from your population. The population that has the mean and the standard deviation that you provided the printout for. Tell me what the sampling distribution for the sample mean for the X bar value would be. There's 3 pieces when we talk about sampling distributions. You should tell me the 3 different parts that we've gone over in the lectures. And then in part D, I want you to use that sampling distribution to tell me the probability that in that future sample of 100 observations, what's the probability the sample mean would be greater than observation number 20. So in part B, is it part B? No, part A, I'm asking you an X problem. In part D down here, I'm asking you an X bar probability. And we've looked at, in the lecture, we've looked at the way that we do X's, the way we do X bars. There's a lot of similarities, but there's one major difference. And I want you to show that. Again, same comments as I did in part A. To get full credit, give me a beautiful picture here. Make it look like what it looks like in the notes. When you watch me do it in class, take a look at how I label things, and then draw me 2 separate pictures. Draw me the X bar picture, draw me the Z. Show me a probability that you're getting from a table, and then give me the answer. Because a lot of times the value we get from the table is not the answer. In fact, in this case, in none of the cases that I put on the project here, you're not going to just go to the table, get a number, and say, there it is. You got to do something with those numbers that you're getting from the table. So show me what that is. And then lastly, in question 3, I want you to use 2 of the techniques discussed in class to assess the normality of the sizes or mileages in your data set. You can choose the 2 techniques. However, if you watch my project video, the 2 that I strongly recommend you do, if you watch the printout demonstration video, stem and leaf display and a normal probability plot. And then I want you to use those things to tell me whether you believe the sizes or mileages are normal or not. So earlier in the class, we talked about the shape of the direction of skewness, skewed left, skewed right, symmetric. Here, your assessment should be based on these plots. I either do believe or I do not believe the sizes or mileages are normal. So this is kind of a normal, not normal assessment that you're giving me here. And that, my friends, is what I'm looking for in project 2. When you have questions, please join us on the online office hours. Or if you're in the live class, join us for live office hours. TAs are waiting, and they're just sitting on their hands, and they're doing other things, which is completely fine, but I'd rather them be answering your questions. Or join me for my office hours. I'd be happy to talk to you as well. So that's what I'm looking for in this project. Go ahead and take a look at the printouts, that demonstration video, and get working early, so that way you can do really well, get your questions answered, and do great. So good luck, and let us know when you have questions. So long.